Imagine stepping outside just after sunset. The air is still, but the sky isn't. A white scar cuts across the twilight, moving too fast to be a plane, too steady to be a meteor. People stop in the streets, pointing phones upward, whispering, "Is that it?" It's April 13th, 2029. Friday the 13th, and the world is holding its breath, because that glowing line in the heavens is no ordinary visitor. It's Apophis, the asteroid once thought destined to strike Earth and tonight. In this version of history, it's coming straight for us. In reality, asteroid 99,942 Apophis is real, discovered in 2004 and named after the Egyptian serpent, god of chaos. It's roughly 340 meters wide, about the height of the Eiffel Tower laid on its side, tumbling through space at over 30,000 kilometers per hour. Scientists calculated that it would pass terrifyingly close, just 31,600 kilometers above Earth, closer than our communication satellites. A cosmic near-miss. But what if the calculations were wrong? What if the smallest nudge, perhaps a jet of sunlight pushing on its uneven surface, shifted its orbit just enough to put it on a collision course with us? Somewhere, a mission controller watches the data. The numbers have changed. Residuals elevated, they murmur. Elevated becomes non-zero, non-zero becomes significant. And suddenly, the word everyone dreads, impact corridor, confirmed. A hush spreads across the world. It's no longer if Apophis hits Earth, it's when and where. The energy of such an impact defies imagination. If Apophis struck our planet, it would unleash more than 1,000 megatons of energy, tens of thousands of times the Hiroshima bomb. The Chelyabinsk meteor that shattered windows across Russia in 2013 was only 20 meters wide. Apophis is 17 times larger. The blast would flatten a metropolis, vaporize everything within kilometers, and send shockwaves that circle the planet. Scientists scramble to predict the target. Impact maps glow red on every news channel, showing corridors of probability wide as countries. Evacuations begin. Some flee, others stay. After all, how do you run from the sky? As the asteroid nears, Earth's gravity begins to twist it. Apophis isn't a solid rock. It's a lumpy, peanut-shaped rubble pile held together by its own weak gravity. As it spins faster, its surface quakes, loose boulders rolling like marbles in slow motion. The tidal pull of Earth stretches it further, turning it from visitor to victim. But gravity doesn't care. It keeps pulling dot, and then the sight of sights. A moving star brightens in the sky, glowing gold, then orange, then blinding white. Entry begins 70 kilometers above the ground, at nearly 12 kilometers per second, 43,000 kilometers per hour. The air in front of it can't move away fast enough, so it compresses, heats, and turns to plasma. The sky catches fire. From the ground, it looks like a sunrise at the wrong time of day. If it hits land, there's no explosion in the traditional sense, just an instant of transformation. The ground liquefies. A crater 5 kilometers wide opens in an instant. The shockwave tears outward faster than sound, flattening forests, leveling buildings, and scattering debris like confetti. The flash burns shadows into walls, then the walls themselves vanish. Even 20 kilometers away, the heat would singe skin and ignite rooftops. If Apophis struck the ocean, the story changes, but the fear remains. The impact would punch a hole in the sea, displacing billions of tons of water. The ocean collapses back in, creating tsunamis hundreds of meters high near the site and tens of meters tall across entire coastlines. The waves don't look like movie walls. They're fast-rising tides that just keep coming. Ports vanish. Cities drown. .inf.rasound. Waves from the impact would circle the Earth multiple times, inaudible but powerful enough to rattle the atmosphere. Satellites might flicker out from radiation or debris. Communication networks could die within minutes. The world's first instinct would be silence, then panic, then disbelief. The aftermath would depend on where the blow landed. A land impact might throw billions of tons of dust and soot into the stratosphere, dimming the sun for months, cooling the planet slightly. Skies would turn copper red, sunsets too beautiful to bear. Crops might fail regionally, but humanity would endure. An ocean strike could cripple global shipping, destroy economies, and erase coastal cities. But even then we'd survive. Hurt, humbled, but alive. And science would rise from the ashes. Within weeks, researchers would swarm the crater-white tents, portable labs, rows of antennas. They'd read the new rock-like scripture. Seismographs worldwide would replay the vibrations. Geologists would slice shocked quartz and melted glass, decoding the pressure of the moment Earth fought back. Even in devastation, curiosity persists. Children would draw the story in crayon. Fireballs with smiling suns because that's how children fix things. Historians would call it Earthfall. Economists would count losses in trillions, but poets would call it rebirth. Governments would vow never again. Planetary defense budgets would skyrocket. Space agencies would fast-track deflection technologies, kinetic impactors, gravity tractors, nuclear standoffs. Humanity would, finally, treat space rocks not as curiosities, but as responsibilities. In the real timeline, this fear inspired action long before the danger. NASA's DARK mission in 2022 struck an asteroid moonlet and successfully changed its orbit, proof that we can move mountains in space. And in 2029, when Apophis really does sweep past, it will serve as a living test. The OSIRIS-HEPAC spacecraft will rendezvous with it days after the flyby, studying how Earth's gravity reshapes its surface. We'll watch from below. A world safe but still small beneath the vastness of the sky. But in our imagined world, this darker, the lesson comes too late. As the dust clears, the sky glows faintly for years with suspended ash. Seasons blur. People rebuild. From orbit, the crater looks like an Earth's eye, open, scarred, wiser. Forests return. Rivers carve new paths. Life, stubborn as ever, creeps back first in moss, then in birds, then in laughter. Humanity, shaken but unbroken, begins again. Decades later, schoolchildren stand at the edge of that crater, their teachers telling them about the day the serpent fell. They gaze into the pit and see reflections of their own faces. They learn that Apophis meant chaos, but chaos didn't win, because even though the universe is vast and indifferent, the one thing that sets us apart is that we prepare, we adapt, and we learn. In another timeline, the real one, you'll see Apophis streak harmlessly across the 2029 sky, a bright dot tracing between the stars. People will gasp, cheer, and maybe feel a shiver deep inside, a reminder of how fragile home really is. For one night, everyone on Earth will share the same sky, the same thought. We are lucky and we are capable, because the truth is, we are not the biggest things in the cosmos, not by far, but we are the only ones who plan. We are the only ones who look at a streak of light and turn fear into science, curiosity into defense, chaos into knowledge. So when you look up that April night and see Apophis gliding silently past, remember this story. In one universe, it was a warning. In another, a wonder. In both, it was a message. The universe is watching and we're finally watching back.